I think that one of the things is something unique about this menu in CoSy is that it actually is executing directly in fourth. Um, so,
Bob, understand it's 20
eh,
minutes?
pardon? Pardon?
Go ahead.
Yeah,
Mute.
you're hearing me okay. What?
Got to shoot the hecklers
I'm,
and mute Mike. Sorry.
I am not muted, right? I'm muted?
I think he
Damn.
said you'll have only 20 minutes.
You're good,
I'm muted.
Bob.
Okay,
You're
fine.
not muted. You're live.
Okay, okay, fine. I just, one of the things is,
Sorry.
um, a point is that CoSy is my notebook, and for instance, I always measure the temperature every day. So, in a sense, this is the point of it. Just to go through F1, of course, is help, and everything is calendar, and F12 puts down one of these calendar lines. And F11, when I hit it, you'll see it puts down a timestamp. So I've got the times that everybody started here, and it saves everything before it puts down the timestamp. And the other important keys here, there are really not that many. Well, when you see something happening in general, it's executing directly in fourth in Riva fourth. The one other key that I'll be hitting, oh, I need to change this. It's actually F8. It goes and opens up a URL. So anyway, here's where my actual um, demo starts, and I'm hitting F8. Over here and get rid of that. And this is my website and so forth. You know, you can find everything going back to 1996 in there. I should mention that I gave a talk at this Lambda conference, functional programming conference, functional language conference, which actually was quite well received and put it was the only presentation that touched on fourth, an APL build in fourth. My most recent newsletter um, goes and it has the links. I lived my I think I've mentioned that my background. I spent the '70s trying to figure out what I could about how brains work, and particularly in the visual psychophysics lab. And it's when I realized that, well, again, to sort of describe the math of optic nerves, for instance, a 250,000 fibers in the optic nerve, but all the different senses there's a lot of similarity between them. But I learned APL when it came around in about 95, um, or 75, because here you had this language which was intrinsically parallel. It didn't, scale didn't matter. You're describing patterns, and I could write a literal definitional Fourier transform in a line of APL. Then actually, when the Byte magazine came out, the original Tron came out, I learned of the existence of fourth, and I'd been working in the lab on a PDP-8 a computer with 6K or 4K of 12-bit words. And when I saw what Chuck had created in fourth, it's like, whoa, This was simply brilliant. Um, in any case, Arthur Whitney created K, which went when APL split into various more complexities and less complexity. Arthur Whitney went in the direction of less complexity and transparency of structure. And one comment that I think Dimitri mentioned, there's several similarities between these two ends of computing language spectrum. Both are interactive. And I'm too clumsy to make any forward progress unless I have a backspace key and can write down a line and have it execute. Both of them are immediately interpretive, and both of them are oriented towards making words, making vocabulary, instead of making what the whole mainstream languages and you're making programs. Okay, when you finally get to having something that you want to call a program, if you're doing things right and it's well factored, you're defining words, a vocabulary to do that. So CoSy is a vocabulary. One of the things for anybody who doesn't know that this text this is clearly my log, and down here I've got things that are, because any line that I put the cursor on, I can just hit F6 and it can execute it. For instance, this line right here goes and grabs all the text in this window, and this is dupe with incrementing, reference count incrementing. This is count. This is swap. And this is splitting it into online feeds. And this is, again, count. And this is connecting them together. So actually, I can execute something like that. And text here contains 78,000, well, close to 79,000 characters. And it's 2,300 lines of code in there. And one of the things to do that, it actually created 2,300 different items. It allocated 2,300 strings for each of those lines, and then just took the count of them and threw them away. So that shows the nature of well, and also the fact that this is not slow. This is a moderate size. It's a 12 centimeter by 12 centimeter by 3 centimeter box right now that this is running on. But one of the things is you can make words at levels below and above standard languages. I mean, these are the two extremes in my perspective. These are outside the normal can of people. It's just amazing how few people are even knowledgeable about the existence of Forth, and even more so than APL. And again, I evolved from directly from Arthur Whitney in, why is that? There it is. KX is extremely competitive in the large data, and now they're getting into this AI growth, but it's market. Arthur spent years at Morgan Stanley and then Union Bank of Switzerland, financed a lot of the creation of K. And so this is a market that's attackable when you have a language that is at this level. And let me hit F6. You can see this is the simplicity, which is far, far simpler than traditional APL. And most fundamentally, CoSy is a time-stamped notebook. And then this is essentially, this is the rules of the simplicity of Forth. The word is any non-blank characters. And the importance of that having space as the prime delimiter Boy, that's man. It opens up a world of words that you can create, and words pass information to each other by pushing it on or off. Pushing it on the stack or taking it off the stack. Then the syntax RPN again compared to where APL has gone. Wow, this is a breath of freshness. And I'll define a noun as any word which takes nothing off the stack and puts nothing on it. And a verb is a word that either does an operation without touching the stack, or takes one or more items from the stack and generally returns a result to it. But this is extremely important, that a verb can look forward in the sentence that it's on. And that's the thing that gives the fourth the ability to actually very simply match the power of any array language. What an APL would be called operators. And I've said tap F6 and it executes. And this is one of the things actually that I was very impressed that the people at the Lambda conference recognized that all nouns are lists, and they're allocated, dynamically allocated, and they have essentially a three-cell header, three-item header in any case. And the first is type. So I'd consider this as sort of a generalization of a counted string. But you have type and then you have count, and those tell how much space needs to be allocated, an address space that gets allocated. And reference count is used by the memory management, the reference counted memory management, which is very much following actually literally a conversation with Arthur Whitney. And when reference count returns to zero, something. Items when you create them. So all of those 2,300 lines that just got split and created, and when their count returned to zero, they are released. This is one thing that I introduced that I really like, and actually for Don, I'd say, boy, do this in parallel with other operations, is do the modulo counting of arrays, because that allows you just leave that. It's been discussed elsewhere, and of course this is just this is simply fourth. But one of the things is there's an extensive vocabulary that goes and does everyday things, splitting, and a lot of it is rather, if you will, geometric, take, drop, reshape. And actually, I've had this conversation with Alan Kay about the fact that what Smalltalk misses is that it fails to understand the geometric nature of data, which APL does. Anyway, enough of that simplicity. Oh, a couple of things, by the way, lessons from Apollo 11. And this you'll see whenever something bombs here, and it's trivial to bomb something when you're executing in raw fourth, in direct fourth, is restart on failure. And on the way down to the moon, actually, Buzz Aldrin did some things that caused the system to fail, but it restarted. And if you see my screen restruct, die and restructure, if I hit something wrong, it has actually gone and recompiled the entire environment, so forth. The other is work at a high level. And that's the point of the APL level of vocabulary, and above APL, like just doing everything practical. So you have a human level vocabulary. they actually, on that incredibly minimal computer, they actually had matrix algebra. In any case, one of the things is that the fourth level, I put it, you're hardware facing. I mean, the whole point of fourth is you have unique openness to the underlying hardware. And it's rather interesting that people are finding fourth useful where they actually are building it on top of, if you will, higher level languages simply because the simplicity of the RPN and so forth is so compelling. And there's this division with human facing levels. If you want anything and you look at any of the languages, they all have essentially dynamic allocation and freeing of column objects. And the simplest object is a list. And that's what, I mean, it's essentially a memory, an address space. And one of the differences here on the fourth side, you have operations that are, if you will, scalar. They're one at a time operations on addressed items. At the human level, you just simply have operations on lists, operations on objects. You're just not be concerned about the computer implementation of it. Most humans will say, "Hey, I'm not a programmer. I don't care about that. I just want to get something done." And again, the fundamental structure, you can make your own type. And type 0 is a list of items, a list of lists. And so you grab that and you've got the count. So all the sorts of loops that you may have to go, multi-line loops, they all are factored into the word, the vocabulary, various forms of loops. And if you don't like you can roll your own type, as long as it fits that. I have a techie dome. And this is sort of the point of that CoSy's at right now. This was Ken Iverson talking with Arthur. Another time when I was concerned about getting credit for an idea, Ken Iverson said, "Arthur, if it's a really good idea, you're going to have to shove it down people's throats." And that definitely is the state that I find. But I invite people to come over to Techie Dome, where I have, I get involved in a fair number of conversations on LinkedIn and other places where I go and essentially, do in CoSy, APL, what other people may do in APLs. And this Connor Hoekstra has done a lot of comparisons with a lot of different languages. This is with BQN is a fancy version of our new version of APL. But here I go through, this actually gets into, that was, I want to go through this very quickly. And I went through, this was a demo of that actually, I have, by the way, it was really great that Brad gave an excellent introduction to the APL side, and we ended up having a significant discussion of that. This is an example that actually Dimitri brought up on Don's APL or AI and robotics. And so here it is gone through in CoSy. Finally, if you're thinking of doing something, again, you are seeing executing in fourth. This is fourth, but it's at a human level, and it has a large vocabulary. For instance, I mean, actually, this is the thing here, all words. There are 2,300 words, and that's all the way from the x86 level language up to the words that are doing, for instance, here, all words that contain CS. Ah, there you just saw it restart. I don't know why that would bomb, but oh, it's because it's got this at the end. Whoops, and now I've probably screwed up the memory a little bit. Let me go and yeah, okay. There are all the words in that 2,300 words that have to do with CSV conversion, to and from database conversions and so forth. Um, so, and again, that went through thousands of creations and destructions of objects. But I'll just say, if you're thinking of doing something in Python, and I know a lot of people in Forth they find Forth simply it's down there talking to the hardware. If you got to do something that just involves something like creating, going through an entire vocabulary, and for that matter, it's probably worth. I wanted to start a timer and I forgot to start it here. I wanted to. Oh, yeah. Here, um, everything is everything is in a tree. That's the thing. The most fundamental structure in CoSy is it's lists of lists. The main list that everything that you see that gets regenerated when something bombs is in a list called R, root. And then DV fetch goes and grabs that and sys is system information. And by the way, one of the reasons why I like Riva Forth is it had a vertical bar comment symbol. So let me put a comment symbol in here. And this is all the lists of all of the different scripts that go into the Forth scripts that go into making up CoSy. And then here, this is one of the generators, which is essentially, I mean, here, this produces a list here, and this says apply this function here to each of those. So actually, this is how many lines are in each of those scripts. So when you go and see, you do something like all words, quote, quote, get the definition of all words, it's gone out through those scripts and found where the colon definition for all words is and returned all those sections that are delimited by totally blank lines. And actually, this is something that blows APL and most other language people away, is that another word I have is C. And there you can see the x86 definition of all words. So this is something that CoSy is absolutely unique in spanning from this high level down to the low level. And if you're thinking of using CoSy or Python for something, contact me. We will get it done faster and more succinctly in Forth and cure you of your snake oil addictions. Okay. Markets, rapid Forth development, because here you can have this powerful array level language to go and do things like you just see, find all the occurrences of anything in all of the scripts, and that's actually only just
Keep rambling.
go and do total couldn't. Anyway, let me just finish up here. Whoops. Oh, I X6 that one. It's a comment. That's what I'm saying. Yeah, this is the market. One of the things is immediately at the ex Lambda conference, a woman I spoke to immediately compared it to Evernote, but except far more powerful because you have this K-level vocabulary to do things. So actually, this is what the level that I'm looking at now and talking to people, including a guy who was the chief scientist at KX, chief, whatever, and Amanda and so forth. So this is the thing, to get away from these concrete walled environments. And I'll just hit F11, and that's the end of my presentation. Questions?
Thank you, Bob. Any quick questions? I'll take that as a no. So our next speaker is a person from the future. He's at 8 o'clock tomorrow in Japan. And these trans-temporal links sometimes crash. So I think that what we'll do is hope for a video from him in December. It looks like an interesting talk. He'll miss the window of having Chuck Moore online, but c'est la vie. We'll maybe ask Chuck to watch the YouTube video at some future time. So I think, Greg, you've been sitting here patiently all day. I expected you to join